Hello, my darlings. Okay, so today we're going to look at doing U substitutions, but we're only given a graph instead of a function. So this is going to be fun. All right, so let's read the stem of this problem. We're given a graph of f. It says the figure above shows the graph of the continuous function f. So I'm going to label this f. The regions A, B, C, D, and E have areas 2. So now because it's below the x-axis, I'm going to write a -2 for the integral. This one is 14. This one is 10, but I'm going to make it -10 because it's below the x-axis. This one is 27, and this one over here is 4, okay? For the open interval from -11 to 7, the function g is defined by g of x equals 8 plus the integral from -5 to x of f of t dt. Now, before I go any further, whenever I see something like this, I automatically, wait a minute, if g of x is that, what is g prime of x? Well, the derivative of 8 is 0, and the derivative of the integral is the function evaluated at the upper limit times the derivative of that upper limit is 1. So we know that g prime of x is f of x. That means that this graph of f is also the graph of g prime. That's going to be important to know, okay? Now, all we've done so far is read the beginning of the problem. Let's see what it is they actually want us to do. So in part A, is there a value of x between -5 and -1 such that g of x equals 0? And we have to justify our answer, so we have to be very specific. Okay, so we know that g prime of x equals f of x. And we know that f of x, because they told us here, is continuous on the closed interval from -11 to 7, okay, which also means it's continuous from -5 to -1, right? Okay, now because g is an antiderivative of a continuous function, which was called f, then g is continuous on that same interval. So not just g prime, but also g. And that means the intermediate value theorem applies. Now, I can't say the mean value because I haven't proved differentiability yet. Okay, so let's take a look here. If we find g of -5, now remember, g of x is 8 plus the integral from -5 to x of f of t dt. So g of -5 is 8 plus the integral from -5 to -5 of f of t dt, which is 8 plus, now the integral from -5 to -5, we didn't go anywhere, that's 0. So this gives us 8, which is a positive number, right? And g of -1 would be 8 plus the integral from -5 to -1 of f of t dt equals 8 plus. Now from -5 to -1, that's that region C, which has an area of 10, but because it's below the x-axis, it's a -10, and 8 minus 10 is -2, which is less than 0. So our function went from positive to negative. Does the function have to be 0 then? Of course it does. Since g of -1 is less than 0 is less than g of -5, right? Because we went from negative to positive. By the intermediate value theorem, there is an x in that closed interval from -5 to -1 such that g of x equals 0. But in order to use the intermediate value theorem, you have to tell us that G is continuous, not just G prime, but that G is continuous. All right, let's try part B. So part B, find the absolute minimum value of G on the interval from -11 to 7 and justify your answer. Okay, so remember, if we're going to look for an absolute max or an absolute min, okay, this time an absolute min, we know that the candidate's theorem says an absolute min may occur at the endpoints, which would be -11 or 7, or where g prime of x, the derivative, is 0, and if I'm looking for a minimum, g prime of x has to change from negative to positive. So on our graph, the derivative is 0 a lot of times, right? A whole bunch of times. It happened here at -11, -9, -5, -1, and 5. But which times is that derivative changing? Because remember, this is the graph of g prime. Is it changing from negative to positive? That's at x equals -9 and x equals -1, right here and here. All right, so now we actually have to find the value. So let's see, let's start at the endpoint, g of -11. So g of -11 is 8 plus the integral from -5 to -11 of f of t dt. Now we can't go from -5 to -11, so it's 8 minus the integral from -11 to -5. When we switch the limits, we have to negate of f of t dt. So now that's 8 minus, now to go from -11, we've got this -2 in here, and then from -9 to 5, we've got 14, so we have to add 14. So if we add all this up, it's 8 minus 12, which is -4. All right, now we're going to find g of -9. That's 8 plus the integral from -5 to -9 of f of t dt. Again, we have to reverse the limits and negate it. So from -9 to -5 of f of t dt. So this is 8 minus from -5 to 5. That area is 14. So we subtract, we get -6. Next up, we're going to do g of -1. That's 8 plus the integral from -5 to -1 of f of t dt, which is 8 plus. Now from -5 to -1, we're in this region C, which is below the x-axis, so that integral is a -10. That adds to -2. Then we have to find g of 7, which is 8 plus the integral from -5 to 7 of f of t dt. So that's 8 plus, now the integral from -5 to -1, that's -10. From -1 to 5, that's a positive 27. And from 5 to 7, that's 4. So we add all that up, we're going to get 29. So now, what is our absolute min value? We are not looking for where it happens, we're looking for the value. What's the lowest number we had? We had -4, -6, -2, and 29. The smallest number is -6, so our absolute min value is -6. They did not ask for where it happens, even though we know that it happens at -9. Okay, same problem, guys. Okay, same problem, but now we want the integral of 2x plus 1 dx. Well, that's just the antiderivative of 2x is x squared, plus the antiderivative of 1 is x, plus don't forget your constant. Nice and easy, right? Okay, now we want the integral from -5 to -1 of f of 2x plus 1 dx. Now we have an outside and an inside. That inside 2x plus 1 is our u, and we need to do a u substitution. So we need to find du dx. Well, the derivative of 2x plus 1 is 2. So if I multiply, du equals 2 dx, and then divide du over 2 equals dx. Now we also need to change our limits. If x is negative 1, that means u is 2 times negative 1, which is negative 2, plus 1 is negative 1. And if x is negative 5, u is 2 times negative 5 plus 1. 2 times negative 5 is negative 10, plus 1 is negative 9. Now we're ready to make our substitutions. Instead of going from negative 5 to negative 1, we're going from negative 9 to negative 1 of f of, but instead of 2x plus 1, it's u, and dx is du over 2. Now that 2 in the denominator is a constant, so we can actually take that over 2 and factor out the 1/2. Okay, so now we have 1/2. So to do this integral from negative 9 to negative 1, here's negative 9, up to negative 5 is 14, and from negative 5 to negative 1 is negative 10, so we have 1/2 times 4, or 2. And there you go, guys. We just did u substitutions from a graph. All right, guys, have a wonderful day, and I'll see you in class.